Now, I think there's something that the Western bike industry as a whole is sort of scared to admit and often tries to cover up, and it's the fact that at this point, some of the world's very best and most advanced carbon bike frames, they're manufactured in China. They've been doing it for decades at this point, and the level of expertise over there, it's almost unmatched. So a few weeks ago, I was in the city of Xiamen in China, which happens to be one of the carbon fiber capitals of the world, and I got some pretty rare access to film inside of a factory that's been operating since the early 2000s. I think one thing that many people don't really appreciate is just how handmade modern carbon bike frames really are. So carbon fiber is such a high-tech modern material, but the application and manufacture in these factories, it's almost akin to like a traditional craft in a way. So yes, certain parts of the process have been standardized, but many of the most important stages, for example, the actual layup of the carbon, are still done entirely by hand. That being said, the methods and techniques used in this factory are pretty cutting edge, and I got to document the whole thing from start to finish. So yeah, let's jump in. Actually, before we continue, it's worth saying I'm not being paid anything by anybody to kind of show this factory tour. While I was over in China, I was there with Joe from Panda Podium. He knew the factory owner, so introduced me, and that's how I got the invite. Joe doesn't even sell any of the frames that come out of this factory. It was just one of those things that kind of transpired while I was over there, and I showed up with a camera. So hopefully that kind of sets the scene. But let's crack on. FiberTek was the factory I visited. So from the outside, the building looks pretty similar to most of the other factories in this part of Xiamen, really. And apart from a few raw frames sitting on racks waiting for collection, you'd never really know they manufacture some seriously high-end bikes here. So they're an OEM supplier, which basically means they manufacture carbon frames and other smaller carbon bits for a range of different companies. Now, unfortunately, I can't actually name any of the brands that they work with, even though this type of arrangement is extremely common within the bike industry. In fact, most major bike brands don't own their own carbon factories. They use this OEM model. It's kind of the way they do business. Needless to say though, some of the brands working with FiberTek are very well known, and in some cases pretty premium as well. Now, as soon as I stepped inside, there were molds everywhere. So each of these is for either a carbon bike frame or a handlebar. Something like that. But yeah, just the sheer volume. And this was only a portion, so should give you some idea of the scale of this operation. Also, these are incredibly heavy, solid steel, hundreds of kilograms each. I tried to lift it and I am an absolute monster, but yeah, no chance. Next was the freezer. Now, they were busy doing a massive production run, so it wasn't super tidy, but the carbon pre-preg, or sheets of carbon impregnated with resin, it has to be stored in a freezer. The resin is heat activated, so once it's taken out and warms up, yeah, the clock is ticking. Now, you can see here, they come on massive rolls, which are then cut up to spec. Now, on the way out to the next room, we passed these EPS and latex forms. Now, I thought that I kind of understood how these worked, but clearly not, at least not in this factory. Now, when you produce a hollow carbon part, you clamp the whole layup inside a mold, but you need internal pressure within there to kind of force the carbon to take the shape of the mold, right? Now, historically, factories have used an air bladder, which essentially amounts to a loose plastic bag to do the job, but they can fold easily, introduce wrinkles into the inner surface, which add weak points. It's not super consistent. To fix that, factories started using EPS or expanded polystyrene forms like these ones. So each one of these is basically half of a carbon fork. Now, I'd always assumed that once clamped inside of a heated mold, it was the expansion of that EPS foam that provided the internal pressure necessary for the part. But that's not how they're used here. As you'll see in a sec, the EPS core is placed inside an airtight bag, which then has an air hose attached later on. And while that EPS core does expand slightly when heated, its primary purpose is just to act as kind of a rigid skeleton or mandrel to help workers more precisely place the carbon. I mean, once you see the layup, you'll understand why it's so helpful, especially when compared to the old process, which was essentially layup over a kind of a floppy plastic air bladder. And it was a similar story for the latex forms, in this case for a frame. I'd assumed the forms were reusable, but generally not, they're single use. But the thing that surprised me the most, each of these latex forms, they're completely rigid. So they basically take an EPS foam copy of the frame and dip that in latex. So the EPS core, that gives a solid foundation for layup, and then that thin latex membrane, that acts as the air bladder. And you can see they've molded hoses into the latex. That's where you'd attach the high pressure air lines to pressurize the form. But yeah, interestingly, each of these latex forms, strictly single use. Right, so all of the footage shot inside the factory in this episode was done on my main camera, this mirrorless Sony one here. But when I'm out on my bike and I need to get some decent ride footage, I now always bring this with me, the HoverAir X1 Pro Max. If you watch my stuff, you'll have seen plenty of footage from this already, actually. I've only had it a couple of months, but pretty quickly it's become kind of indispensable in terms of my camera gear. When I'm out getting riding footage, it's just me. There's kind of no one else there. But when I've got this with me, it's pretty much like having a separate cameraman. You can pick up shots like this, which are awesome. So you just select the orbit mode, fine tune 1 or 2 parameters in the app, hit a button, it will take off from your hand, track you as it goes round, and then when it's finished, it'll come and land directly back on your hand, kind of where it started. It'll zoom right out so you can get nice wide establishing shots, but it's got loads of other modes. I obviously use the cycling one all the time, so you just set off and it'll kind of track behind you and follow where you cycle. Plus, it'll go up to 26 miles an hour, which is pretty rapid for this little thing. You can also control it manually like a more traditional drone, either through the app on your phone, or you can get these joysticks as a kind of add-on, and I've got them, they're quite good actually. I got this footage in manual mode the other day, and yeah, it does look pretty good. I shoot in 4K 60, but it'll shoot up to 8K, which is, yeah, pretty nuts. But it's just a really cool bit of kit. So if you want to check it out, link in the description. So thanks to HoverAir for sponsoring this one, and let's get back to it. Right, onto the cutting room. So this is basically where those huge sheets of pre-preg are kind of cut up into the desired shapes. In this case, it's a combination of cutting strips with this guillotine. You can see the guy loading strips in. An initial press holds the sheets in place and the guillotine comes down. I'm kind of laughing because it doesn't come across on camera. It's really, really loud. That thing would remove fingers or limbs. Yes, so easily. Next up was this press. You can see the guy dip a tool, basically a steel punch die, into some grease and then place it on top of a stack of carbon. Then after being squished, you get these. The cutout in the middle is discarded, and these are actually destined to reinforce the seat tube area on a frame. There was a whole rack of those steel dies separated by component, obviously various shapes to suit the layup and kind of specifications of different carbon frames or parts. Now at this stage, the pre-preg is quite tacky, so you'll notice some sheets have a white protective film on both sides. These are generally structural pieces, so you won't see them, while those that have the film on one side are more cosmetic. This is a good example, so this will be used on the very outer layer to give the carbon a marbled effect, which has become, yeah, quite popular recently. And interestingly, I tried to show it, the carbon, it's almost hairy, actually, and we'll see this used later on. Now, on the way out, Joe, who I was with, pointed this out, and it's, yeah, quite interesting. So the racks of cut pre-preg, they're all labeled up. So on this rack, it's a size 45 frame, and there's enough here for 12 of those, while the rack below is for a 56 centimeter frame, and yeah, there's enough for 64 frames in here, so you can sort of see the production numbers in action in the factory. Anyway, on to layup. So you can see each worker, they had a stack of pre-preg organized in little shelves in front of them, and hung up here was essentially like the recipe card for the frame she was working on. So this is one of those hybrid latex molds, and as you can see, they've wrapped the entire thing in plastic. Now, interestingly, latex doesn't chemically bond with epoxy resin, but it can mechanically kind of grab on to some of the carbon fibers, especially when squeezed under pressure. Now, I actually demonstrated this in a previous video. This frame had some loose fibers down the seat tube for this very reason. When the form was pulled out, it pulled some fibers with it. Definitely not a huge deal in this case, hasn't affected the frame structurally in any way, but yeah, a plastic wrap can help avoid this, and it's what they've done here. Anyway, the layup has just started here, and you can see these are the reinforcement patches for bottle cage riv nuts. Now, cheaper frames will often skip this step, but it helps ensure the riv nuts have something to grab onto, and hopefully you can see in this endoscope footage I took inside of a frame, you might be able to see those patches actually. Now, the layup continued as per the recipe. She's just constructing the head tube here, and you can see her peel the backing from a patch of pre-preg. Now, as mentioned, it's quite warm and tacky at this stage, acts almost like a sticker, so she can just place it down and it won't shift. But while she was working, I noticed this. Each bench had an airline, so during layup, they seal off the top of the latex form with a rubber band and attach this hose and use it to pull a vacuum and remove any wrinkles from the latex or that plastic bag, just doing everything they can to ensure consistency at this stage. I also spotted these, and at first I wasn't really sure what they were for, but turns out these are the T47 bottom bracket shells. So these get inserted into the frame. I've got a shot of that here. It then gets baked and cured, and later on
the threads are cut into each side. So you can also see here all the different layers of carbon that get added. Apparently each frame has 200 to 300 patches, all laid by hand. Now some areas like the down tube have long continuous pieces, while other more sort of intricate areas like the bottom bracket have loads of different patches. Sort of looks random, but each patch is carefully placed according to that recipe. Now these are the headset bearing seats. This one is kind of wrapped up and ready to be inserted. But if I take an unwrapped form, you can see that 45-degree angle in there to match the headset bearings. Yeah, pretty flippin' cool. So they also had some carbon handlebars laid up and ready to go. They were using that marbled carbon I showed earlier for the external finish. And these are the drops. So they tend to be kind of separate pieces glued together, and I got to see that process later on. So yeah, stick with. Next to them were a set of chainstays, and interestingly, some of them had the airline hookups attached to the air bladder, and these ones were just having them added on. Again, they used that marble effect carbon finish externally, and I also saw the aluminium inserts they add for the rear brake mounts. And yeah, honestly, all of this was just really, really cool to see in person. Around the corner, it was a bit earlier in the process. This is an EPS form for one of those forks we saw earlier, wrapped in a bag, and you can see here she's adding the vacuum line onto the end and manipulating the bag to suck out all the air and remove the wrinkles. After that, she moves on to layup, and if you look at the end, you can see the aluminium inserts for the front brake mount as well. On the table over, there was a lady doing layup on one of those handlebar drops. She's nearly finished and uses a hairdryer to keep the strips of pre-preg kind of warm and malleable. But yeah, this is a perfect example. Raw EPS form here, and below, yeah, the completed product ready for the mold.
So yeah, hopefully it's clear just how manual this process still is. I mean, yes, certain steps are standardized and the workers follow quite a strict recipe sheet, but every piece of carbon is laid by hand. It's sort of a juxtaposition. You've got this aerospace grade material, but the layup process is almost quite artisanal, quite handmade, if you will.
Right then, on to baking. So these are some seat posts and handlebars that they've got ready to go. They've got the airlines attached to the bladder, and you can see them here loading a few of them into the ovens. Now here's a chainstay, literally fresh out of the mold, and it was almost too hot to hold. Actually, they get baked at about 150 C, so pretty toasty. And yeah, it does look a little rough here. The thin translucent edge is called flash. It's basically excess resin and a few bits of carbon that were aggressively squeezed out of the parting line of the mold under kind of pressure during the bake, but it gets easily scraped off and kind of sanded down later. You can see the routing hole for the rear brake line there, and you can also make out those aluminium inserts for the rear brake mount. Now right here, they're prepping a frame mold, blowing out any leftover resin from the last bake, and you might be able to kind of see in the back, the top half is attached to a hydraulic ram because, as mentioned, these solid steel molds are incredibly heavy. This is the raw frame about to go in the mold, and these patches down in the bottom left are quite interesting. So here's one close up. Now it might not be immediately obvious what they are, but they're actually the cable routing guides. So these go into the mold first, and you can see them already positioned in this shot here. Next, a bit of mold release is applied, and then the frame is lowered into place. You might also notice all of these separate mold inserts at the bottom here. These are used to form the kind of undercuts and other complex areas of the frame, but the guy on the right is installing the inserts that form the upper and lower bearing seats of the head tube. They also use one for the bottom bracket to ensure those BB cups retain alignment during the bake. So yeah, it's not just a case of kind of throwing the layup into a mold, closing it, job done. Each time takes a bit of fettling, and yeah, the molds themselves are quite complicated. Anyway, here they are lowering the top half down with those hydraulic rams, adding in some pins to retain alignment during the bake, and yeah, that's it, in it goes. Now each bake takes about 45 minutes. Essentially, there's a massive hydraulic ram underneath to kind of compress the molds. Air lines get added to pressurize the forms, and yeah, it's actually the plates or platens between each mold. They've got hot steam circulating around them, which is what actually provides the heat for the bake. Interestingly, they don't actually generate their own steam, so instead it's supplied through these centralized pipes outside, and it's a government-run steam network. I had never heard of this before, but apparently it's quite common for industrial areas in China and other parts of the world. But yeah, this was completely news to me. Now, unfortunately, I didn't get to see the extraction of a frame, although I did see this fork getting removed. And yeah, it looks like the brake mounts are pre-threaded here, and they use a separate form inside the mold itself, which is kind of what's being removed here to ensure things are aligned while it bakes. You can also see the 2 air lines out the top here for each of the fork arms, and on the way out, I spotted this water bath. They basically submerge parts straight out of the molds in here to ensure the bladder inside is still airtight. If not, bubbles will kind of rise up and the internal pressure won't have been maintained while baking, so the layers won't have compacted, and yeah, the part is scrapped. Anyway, back onto the frame. So after a bit of finishing, the rear triangle needs to get added on. The exposed ends of the frame here, they get some epoxy added, and then it gets placed in a jig. To ensure the rear triangle retains alignment, the head tube is held in place. The rear dropouts, they're also bolted down along with the bottom bracket area. It's then placed inside a secondary oven like this one to cure the glue. In fact, when I've looked inside a few frames, you can actually see this glue on the inside of the chainstay. You can see some of it has kind of squeezed out around the edges here. There were a few forks getting glued up too. These ones have an aluminium steerer tube and carbon fork arms, and you can see the glue here is still kind of fresh and shiny, and again, they're getting loaded onto a jig to ensure they're kind of aligned while baking. These ones have literally just come out of the oven. You could feel the heat kind of radiating off them, and hopefully you can see there's a little bit of a recess where they've been glued. You can also see it on this pile of finished handlebars. The glue gets sanded back, and then additional carbon gets wrapped in this area to increase the strength. It's the same principle for frames. You can see that here. This one has been glued, and the areas have had that additional wrap of carbon. This one is on the chainstay next to the bottom bracket area. As it happens, the BB threads haven't been cut yet, and yeah, this is another wrap down by the rear dropout. These will obviously get sanded flat, but before that, a bit of QC to make sure they're up to snuff. No point going any further if they're out of spec. Checking the front derailleur inserts here, making sure they haven't migrated at all. During the bake, you can see they're threaded, ready to go. This lady is just checking the internal and external diameter of the steerer tube, actually, and they also check things like the cable routing path to ensure there are no blockages for the kind of brake hoses, in this case on a carbon fork. They do a few more dimensional checks, and this guy is finishing out the headset bearing seats, but they also make mountain bike frames too, so need to ensure the swing arm bearing seats are up to snuff as well. After that, quality control is wrapped up and it's over to paint. Now, I asked to see it, but it's a dust-free clean room, and yeah, they were in the middle of a big production run, so I couldn't get access. But interestingly, these frames here were left raw, and that's how they're being shipped out. The manufacturer wants these painted in Europe. I think it was Italy. Now, talking hypothetically, I truly have no idea. Even though the bike is painted and presumably assembled over there, I don't think that brand would be able to legally claim it's made in Italy, but they might use some other wording like designed or assembled in Italy, or born in Milan. You might see something like that on the marketing. That kind of language, yeah, it's quite common in the bike industry, but yeah, interesting to see it in person. After that, down some stairs to the packing room. Nothing particularly interesting in here, and then we were taken to a little showroom. We got to see some frames I believe a sister company of theirs was working on, part titanium, part carbon. Admittedly, a little rough on some of the joints, but these were just prototypes. They did look really, really cool though, especially the bottom one. It uses 3D printed titanium lugs bonded to carbon tubing. I've seen a few frames like this in the past, but mostly from kind of Western boutique builders. Bastion Bikes in Australia or Passoni in Italy come to mind, but those bikes are incredibly expensive. So yeah, clearly China is catching up in that department. I'll be interested to know what these sell for when they hit the market. And lastly, we ended up in the testing room, and this was really cool. Essentially, a brand will come to FiberTek with a frame design, they'll co-develop it, and then it'll end up here where they stress test it. This is a carbon fork, presumably for a road bike, and yeah, it's really flexing there. Just look at where that lower bearing would sit. The gap is really opening up. Pretty impressive, really. This is a road bike frame clamped at the head tube, basically simulating the kind of forces from pedaling, although I'm not sure many of us could sustain that level of sprint for any meaningful distance. And yeah, this one was putting the bottom bracket shell itself under repeated load. Interestingly, all of the actuators had these load cells on, so they can tell if a frame cracks or gives out, because yeah, the load will drop, and then they can tell how many cycles it took and how much force was applied before it failed. But yeah, honestly, all this stuff, it was so cool to see in the flesh.
So I hope I've made it clear, carbon frame and part manufacture is still an incredibly manual and involved process. After seeing it in person, I can understand why so many brands will outsource to an OEM factory like this one. It's not just a case of buying some molds and throwing some pre-preg in there. There's so much skill and experience required, and a level of craftsmanship as well that I don't think I was kind of expecting going into this. But yeah, just so cool to see. Obviously, massive thank you to FiberTek for inviting me down and letting me film. I've put their details in the description in case you want to get in touch. And yeah, big shout out to Joe from Panda Podium for helping out as well. While I was in Xiamen, I was hanging out with him and his family, and they're all just, yeah, really, really great bunch. So big shout out to him. Right, anyway, that does it. I'm gonna go and you know, have the rest of my day. So I'll see you in the next one. All right, ciao, ciao.
It's the bonus clip time.
Right, forgive me, ladies and gents. I've got to flex on you for a second because I've got one of the sickest road bikes to build up this afternoon, and it's right behind me. Pow! Look at that. So yeah, it's the flipping Lego road bike. I mean, how cool is that? So this kit has literally just come out and a couple of friends of mine bought it for me. So thank you so much. But yeah, it's got disc brakes. I think the chain goes round as well. So yeah, how cool is that? Just gotta flex on you with some exclusive builds. So yeah, I'm gonna crack on with that this afternoon. Oh, also, I guess this is quite interesting. I got this from AliExpress the other day. So it's disc brake cleaning gel. I mean, I've basically on this bike here, the rear disc brake is a little bit squeaky, and I've tried a couple of different things to remedy it. I've used, yeah, you know, the standard stuff. So where are we? Isopropyl alcohol, acetone on there, and brake cleaner stuff. And I've cleaned the pads and the disc, but the squeal is still there. And I think this stuff actually etches the surface of the disc brake very slightly. So I'm interested to see if that works as well. So I'll report back. Anyway, yeah, thanks for sticking with, and I'll see you next time.